Hey dude, thanks for visiting. Hope all you are doing well. So we meet after a long vacation. So at first all, today is 1st January 2024, and so happy new year to all. Okay, so in this session we are going to solve the वेस्ट बंगाल सेट 2023 पेपर जो दिसंबर में अभी हुआ, ठीक है। सो उस पेपर का इस सेशन में डिस्कस करेंगे ओडी, पीडी, न्यूमेरिकल, फूरियर एंड लैप्लास। ओके, so let's start, and before starting I'm requesting you to all those who are new in my channel, and if these sessions or if the videos of this channel is helpful for you for your preparation of any higher mathematics exam, then don't forget to give a like, and obviously you can do again comment if you have any query, and if you are new here then you can obviously subscribe the channel. Okay, so let's start this lecture. Okay, so the first question is from OD. Okay, so the question says that let Wt be the Wronskian of two linearly independent solutions of the ordinary differential equation 2y dash. So 2y double dash plus y dash plus t square y, this is equal to 0, t belongs to R. Then the what is the Wronskian, that is Wt. Then for all t there exists constant t such that the Wt is the Wronskian, so we can find easily the Wronskian. So we will know that by Abel's formula, we will know that Wronskian of t, this is equal to some constant. Here the constant in all the cases are c, so we take here c into e to the power minus integration. Okay, the coefficient of the y dash, okay, the coefficient of y dash, that is this is 1, and the coefficient of y double dash term, this is 2, and this is with respect to dt. Okay, you all know that if the differential equation is p0 y double dash plus p1 y dash plus p2 into y, this is equal to something q or 0, homogeneous or non-homogeneous, then the Wronskian is given by e to the power minus integration p1 by p0 into dt or dx, in which variable the differential equation is given. So this is equal to clearly c e to the power minus integration, sorry, not integration, this is c to the power minus simply t by 2. Okay, so this is the answer, and this is option B is the correct one. Okay, and these question numbers are from X series. Okay, so you can check the questions. Okay, now let's come to the next question. So the next question is the general solution of the ordinary differential equation d2y dx2 plus y, this is equal to fx, where x belongs to minus infinity to infinity, where fx is the continuous real valued functions from minus infinity infinity. So you can solve this problem by using the fx by any particular value, that is you can take the fx equal to 1, and then you can solve the differential equation and check whether by putting fx equal to 1 in these four options you can check. Okay, but here we solve using the what if we derivative these four options. Okay, okay, so see, if this derivative, then only cos and sin terms comes, but see one things, if d2y dx2, if we write the CF, that is complementary functions of this differential equation, that is the solutions of the differential equation corresponding to homogeneous system, so we all know that the auxiliary function is m square plus 1, this is 0. So we all know that m equal to plus minus iota. Okay, so and we all know that if the plus minus iota comes, then the complementary functions becomes a cos x plus b sin x. Okay, so देखो a cos x plus b sin x, that is option A, you can discard. Okay, now here option B, C, D and cos signs are all present, so you can check by taking the derivative of this y. So see, we check here the fourth options. Okay, first, or you can check any other options. So see, if we check the option D, then this is y equal to a cos x plus b sin x plus integration 0 to x ft into sine of x minus t dt. So if we derivative, so y dash equal to minus a sin x, okay, minus a sin x plus b cos x plus integration 0 to x del x of this term, that is ft into cos x minus t dt plus देन क्या होता है, x पुट करेंगे एफ एक्स इंटू साइन ऑफ x माइनस एक्स and this is d dx of x. Okay, so this term goes to 0 because there is sin 0, so this term vanishes to 0. Now if we again derivative this y dash, so we get y double dash, this is equal to minus a cos x, this is minus a cos x plus b, sorry, this is again minus b sin x b sin x plus integration 0 to x, this is ft, and if we del x of these terms means minus of, so here we put minus, okay, minus of cos x minus t dt, and then this goes to plus integration, no, not integration, then we put the all the terms in x, so fx into cos x minus x and derivative ddx of the upper limit, and since lower limit is 0, so we can I am not write this second term, the next term is the lower limit into derivative of the lower limit into this term x we put. Okay, so you all know that this rule for the differentiation over integration. Now so this is equal to what, this is equal to देखो minus a cos x minus b sin x minus integration this one. Okay, so integration sorry cos, so this is also sin hoga, not cos, because here it is cos, so it is again sin. Okay, so see minus a cos x minus b sin x minus this integration, and this is equal to what, this is the y again, so we put here y minus of y plus this is fx into cos 0 and this is 1, so this is plus fx. Okay, so this becomes y double dash plus y is equal to fx, and which is the given differential equation. Okay, so option D is clearly the correct answer, and you can also discard by this way, by these two options B and C. ओके, बी एंड सी को डिस्कस कर सकते हो ऐसे ही आप चेक करके, ठीक है। मैंने डी ऑप्शन नहीं किया क्योंकि डी ही इसका आंसर है, अदरवाइज यहाँ पर टाइम ज़्यादा लगता है, ठीक है। तो ऐसे ही आप सॉल्व करोगे तो सिमिलरली बी एंड सी को आप डिस्कस कर सकते हो, ठीक है। नेक्स्ट क्वेश्चन देखो, कंसिडर द डिफरेंशियल इक्वेशन दिस, then which of the following statements are true? 0 is ordinary point and singular point, and here 4 options are given. So if we rewrite the differential equation by this way, d2 by dx2 plus x by x square into 2 minus x into dy dx plus 2 by x square into 2 minus x into y, this is equal to 0. Now if we compare this differential equation y double dash plus px into y dash plus qx into y, this is equal to 0, then we all know that px, this is equal to what, x cancel 1 by x into 2 minus x, and qx is equal to what, qx is equal to 2 by x square into 2 minus x. Now we all know that if the limit, so here the singularity point is 0 and 2, we can easily see, but what types of singularity? So here option A says that 0 is an ordinary point. Ordinary point means there is no singularity, but there is singularity. Okay, so this option is not correct. Okay, now here option C says that x equal to 2 is an ordinary point and x equal to 0 is regular singular point. Because of this portion, this option is also discarded. Okay, so and option B says that x equal to 2 is the only singular point. This also discard because x equal to 0 and 2 both are singular point. So option D is the remaining answer. 0 and 2 are regular singular point. Okay, so you don't have to solve this problem, okay, to answer this problem. Okay, so if you see these types of, मतलब जो ऑब्जर्वेशन है वो थोड़ा सा अच्छा होगा तो आपको सॉल्यूशन करना ही नहीं पड़ेगा, ठीक है। अदरवाइज हाउ कैन यू चेक दैट दिस इज वेदर इट इज रेगुलर सिंगुलर पॉइंट और नॉट? So you just check limit x tends to 0 or 2 x px, or if you check for x equal to 2, then limit x tends to 2 into x minus 2 px. This limit for case, this is case of 0. If this limit exists, then we say that 0 is the regular singular point, and if this is limit exists, then we say that 2 is the regular singular point. And similarly limit x tends to 0 x square qx for 0, these two cases are for 0, and these two cases limit x tends to 2, x minus 2 whole square into qx. If this limit exists, then we say that 0 is the regular singular point, and if this limit exists, then we say that 2 is the regular singular point. And you can easily check that these four limits, so for x tends to 0 these two limit, and for x tends to 2 these two limit, both are exist. So we can see that 0 and 2 both are the regular singular point. Otherwise you can if you don't solve these questions, or you don't need to solve these questions actually, okay. So because of this observation you can easily say through the options, okay. Now the next question. So the eigenvalues of the boundary value problem, so this is also from OD. So the eigenvalues for the boundary value problem, d2y dx2 plus lambda y equal to 0, and here 4 options. So this is very easy questions. So we all know that the solutions of this problem is, I directly write a cos root lambda x plus b sin root lambda x. I think you all know that how to write this one, because the auxiliary equation is m square plus lambda equal to 0. So the root is m is equal to plus minus root lambda iota. Okay, fine. So there go. So it is given y0 and y dash. So we can first find y dash. So y dash equal to a minus a root lambda sin root lambda x plus b root lambda cos root lambda x. Now first it is given y0 equal to 0. If we apply y0, this is 0, then we find here from here, so we get 0 equal to a, and this term 0, this gives a equal to 0. Now the solution is becomes y equal to b and root lambda, sorry, b sin root lambda x, okay, b sin root lambda x. So this differentiation is irrelevant because this term is not present. So y dash equal to क्या आएगा, b root lambda sin root lambda x, okay. So y pi minus y dash pi equal to 0 gives y pi minus y dash pi, this is equal to 0, gives 0 equal to y pi means a cos root lambda pi plus b sin root lambda pi minus of what, y dash pi means b root lambda sin root lambda pi, okay. At pi this is b root lambda sin root lambda pi, and this is equal to 0. So this gives, देखो क्या आएगा, एंड a तो 0 है, ठीक है, तो a का तो कोई काम ही नहीं है, इस टर्म का तो 0 ही आएगा आई थिंक, और जस्ट अ सेकेंड, y पाई प्लस y डैश पाई, सॉरी दिस इज कॉस रूट लैम्डा आएगा ना, मैं तो साइन ही लिख दिया, तो ये आएगा आपका कॉस, ओके। तो देखो ये टर्म तो नहीं आएगा, ठीक है, क्योंकि b साइन रूट लैम्डा है, तो देखो b साइन रूट लैम्डा पाई दिस इक्वल टू b रूट लैम्डा कॉस रूट लैम्डा पाई, ओके। देखो if b equal to 0, here a is 0, if b, again b equal to 0, then a b both 0, and from here this is the solution, so we get trivial solution, but we are interested in non-trivial solution to find the eigenvalue, okay. So that means here b not equal to 0, that means we can delete b from both sides. So sin root lambda pi this is equal to root lambda cos आपके पास root lambda pi, okay. So this gives tan root lambda pi, this is equal to root over of lambda, okay. And if we take lambda equal to k square or k n square for notation, then this gives tan k in pi, this is equal to k n, or k equal to for 1 to 3 and so on. So देखो कौन सा ऑप्शन ट्रू है, ये वाला ऑप्शन सी ट्रू है. इफ वी टेक लैम्डा इक्वल टू k square and then this is are the roots of k equal to tan k pi. Okay, so option C is correct here. Next question, this is from PD. Okay, तो देखो क्वेश्चंस क्या बोला है, क्वेश्चंस बोला है कि the initial value problem del u del t plus x del u del x equal to x for 0 less x less equal to x less equal to 1 t greater than 0 and u x 0 equal to 2x has कौन सा ऑप्शन ट्रू है. यूनिक सॉल्यूशंस, मोर देन वन सॉल्यूशंस, ए सॉल्यूशंस विच रिमेन बाउंडेड एंड नो सॉल्यूशंस. देखो ये मैंने वो जो मतलब मे भी एग्जाम में ये जो किया था वो मेरा गलत हो गया, क्योंकि मैंने वो सिर्फ जो P0 dx0 बाई dt जो करते हैं ना, वो मैंने किया था, तो उससे गलत हो गया था मेरा, तो उससे ये सॉल्व नहीं होगा। मतलब आई थिंक आप समझ सकते हो ना कैसे किया था मैंने। P बाई dx0 dt इज इक्वल टू Q बाई dy0 dt, ऐसे जो था ना, इक्वल होगा नॉट इक्वल होगा, तो ये सब जो था वो यहाँ से नहीं होगा, ठीक है। तो देखो कैसे होगा, फर्स्ट इसको सॉल्व करते हैं बाय यूजिंग लैग्रेंज मल्टीप्लायर मेथड, क्योंकि देखो यहाँ पर यूनिक सॉल्यूशंस बोला है एट व्हिच इज टेंड्स टू इन्फिनिटी, एंड ये जो है ये सॉल्यूशन व्हिच रिमेन्स बाउंडेड एट टी टेंड्स टू इन्फिनिटी, ये दोनों ऑप्शंस के लिए ये यहाँ पर एप्लीकेबल नहीं होगा, ठीक है। तो देखो सॉल्व करते हैं फर्स्ट। सो डी टी बाई 1 दिस इक्वल टू डी एक्स बाई एक्स, दिस इक्वल टू डी यू बाई एक्स अगेन, आई थिंक आई राइट इट क्लियर, ओके फाइन, सही है। तो देखो फ्रॉम दिस टू रेशियो वी कैन राइट डी एक्स इक्वल टू डी यू, and if we integrate then we can write x equal to u equal to x plus c1, okay fine. Now next if we take these two ratio, then dt equal to dx by x, so if we integrate then we can write t equal to log x, or yeah, t equal to log x plus c2, if we write log x और log c2 ले लो, ठीक है, माइनस log c2 ले लो, log c2, then we can write x equal to c2 e to the power t, ओके c2 x by c2 ओके e to the power t। तो देखो नेक्स्ट तो यहाँ से क्या लिखेंगे, c2 इक्वल टू x e to the power माइनस t, ओके। नाउ इफ वी राइट c1 equal to phi of c2, this is the solution phi c2, then क्या होगा यहाँ से c1 means u minus x, this is equal to phi of c2 means x e to the power minus t, okay fine। तो now if we put u x0 equal to 2x, okay, so u x0, now यहाँ से लिखते हैं u x0 this is equal to 2x, so u की जगह लिखेंगे 2x minus x from this equation, okay, from this equation minus x this is equal to phi of x into e to the power t की जगह लिखेंगे 0, तो ये आएगा 1, दिस इम्प्लाइज phi इक्वल टू क्या आएगा x, देखो phi इक्वल टू phi x और phi x इक्वल टू x minus x x, so the solution becomes what, so from here the solutions becomes u minus x this is equal to x e to the power minus of t, so this implies u equal to x कॉमन लेकर 1 प्लस e to the power माइनस ऑफ t। तो देखो एज t टेंस टू इन्फिनिटी क्या होगा, t टेंस टू इन्फिनिटी ये टर्म्स तो 0 में जाएगा, ठीक है। तो ऑप्शन यहाँ पर बोला है, क्या बोला है, यूनिक सॉल्यूशन व्हिच टेंस टू इन्फिनिटी एट t टेंस टू इन्फिनिटी, नो दिस इज नॉट करेक्ट। मोर देन वन सॉल्यूशन, देखो यहाँ पर तो कोई मतलब कांस्टेंट नहीं है, तो मोर देन वन सॉल्यूशन भी नहीं होगा। ए सॉल्यूशंस व्हिच रिमेन्स बाउंडेड एट t टेंस टू इन्फिनिटी, देखो t टेंस टू इन्फिनिटी होगा तो ये टर्म 0 में चला जाएगा, सो u इक्वल टू ओनली होगा x, एंड यू कैन बाउंड, क्योंकि यहाँ पर देखो x का जो बाउंड्री है वो 0 से 1, ठीक है। तो t टेंस टू इन्फिनिटी x होगा, एंड x तो बाउंडेड है यहाँ पर 0 एंड 1 में, दैट इज दिस ऑप्शन इज करेक्ट, ए सॉल्यूशंस व्हिच रिमेन्स बाउंडेड एज t टेंस टू इन्फिनिटी। नाउ नेक्स्ट क्वेश्चन, तो दिस इज क्वेश्चन नंबर 40, इट सेज दैट अ जनरल सॉल्यूशन ऑफ द पार्शियल डिफरेंशियल इक्वेशंस del 2 z del x2 minus a square del 2 z del y2, I think you all know that these types of equations, so z xx minus a square z yy, if these types of equations here, then we can write the auxiliary equation is m square minus, if we auxiliary equations by putting m d equal to m and d dash equal to 1, okay, where d stands for del z del x and d dash stands for del y, okay, so m square minus a square this is equal to 0, so the auxiliary equations roots are m is equal to plus minus a, and these are the roots, then we generally, if m is the roots of this different roots or distinct root, then how can we write the solutions of this differential equation, so z equal to, we write phi of y plus, if m1 m2 are the distinct roots, m1 and m2 are the distinct root, then ay plus m1x plus phi 2 phi 1 phi 2 y plus m2x, and here the value of m are plus a and minus a, so this is phi 1 y plus x ax and plus phi 2 y minus mx, sorry minus ax. Okay, and phi 1 phi 2 are the arbitrary function. So देखो यहाँ पर phi 1 phi 2 जगह f and g है arbitrary function. So देखो y plus ax and y minus ax होगा. देखो option a plus is y plus ax and y minus ax. Yes, this is true. Minus ax gx, no. Then y plus x x minus y, no. Then y plus ax gy, no. Okay, so option A is clearly correct one. Next question, and this is from the Fourier cosine transform. Fourier cosine transform. ओके, तो देखो इसका आंसर क्या होता है. फर्स्ट इस क्वेश्चन को सॉल्यूशन एक बार देख लो. मैं लास्ट में वो फूरियर का क्वेश्चन कर रहा हूँ आपको, ठीक है. तो देखो द लैपलास ट्रांसफॉर्म exists when the functions is piecewise continuous, exponential order, piecewise discrete and of differentiable order. ठीक है, तो ये आप जो लैपलास ट्रांसफॉर्म का एग्जिस्टेंस का जो सफिशिएंट कंडीशंस का एक थ्योरम है वहां से देख सकते हो. इसका 2 पॉइंट ही ट्रू होता है. लैपलास ट्रांसफॉर्म एग्जिस्ट व्हेन दिस इज पीसवाइज कंटिन्यूअस एंड दिस इज ऑफ एक्सपोनेंशियल ऑर्डर. तो ऑप्शन ए एंड 1 and 2 आर करेक्ट एंड जो बाकी दो है वो है इनकरेक्ट. ठीक है, दैट इज व्हिच ऑफ द फॉलोइंग ऑप्शन आर करेक्ट. 1 and 2 ओनली, बाकी ए बी सी एंड डी आर बी सी डी आर डिस्कार्डेड. ओके, नेक्स्ट क्वेश्चन. दिस क्वेश्चन इज फ्रॉम न्यूमेरिकल एनालिसिस. ओके, देखो Newton Cotes formula, if fx is the interpolated at equally spaced nodes by a polynomial of degree 2, then it represents what? Trapezoidal, Simpson-One-Third, 3/8 rule or Bool's rule. So fine. So we all know that the Newton Cotes formula is the general formula for numerical integration, and in this Newton Cotes formula we put different orders polynomial to get one by one methods. Okay, that's why the first method is trapezoidal, second one is Simpson-One-Third, next is Simpson 3/8. These types of rules we put a particular order polynomial in the Newton Cotes formula and get this, okay, formulas. Okay, so देखो for the trapezoidal rule this we put a first order polynomial ax plus b. Okay, so this is linear polynomial भी बोल सकते हो आप. So in Newton Cotes formula and in the Simpson 1/3 rule we put a second order polynomial f is equal to ax square plus bx plus c type का polynomial. Okay, and then in Simpson 3/8 rule we put f is equal to a general third degree polynomial ax cube plus bx square plus cx plus d. These types of if we increase the order of the polynomial, then we get the different forms of integration, numerical integration. Okay, so here the polynomial of degree 2, that means it represents obviously the Simpson rule. Okay, Simpson rule means here Simpson 1/3 rule obviously, because in C option it gives 3/8 rule. Okay, so that's why Simpson rule means Simpson 1/3 rule. It you have to mean that this is Simpson 1/3 rule, not 3/8, because here in other options 3/8 is mentioned. So that's why option B is correct here. Okay, now also this मतलब जो Simpson 1/3 rule का बोलता है, ये पैराबोला भी कभी कभी बोलता है. ठीक है, पैराबोला भी कभी कभी बोलता है, पैराबोला रिप्रेजेंट करता है, ये भी बोलता है. ठीक है, नेक्स्ट क्वेश्चन. So and next question and last questions of today's class. So it is very basic problems of numerical analysis. So the values of a b c such that integration 0 to fx fx dx 0 to h fx dx is equal to this approximation, so is exact for the polynomial of degree 2r. Okay, fine. So how can we solve these types of problem? We all know that, I think. So if we put first 1 degree polynomial, then of 0 degree polynomial, 1 degree polynomial, then 2 degree polynomial, and calculate these terms. Okay, so if we put fx equal to 1, then this gives 0 to h 1 dx. This is equal to what? H into a, f0 means 1, f h by 2 means all are 1. So a plus b plus c. So this implies this is h equal to h into a plus b plus c. So this means a plus b plus c is equal to 1, as h not equal to 0. Okay, so a plus b plus c equal to 1. So we can discard options by verified this case, a plus b plus c equal to 1. So see in option A, 0 plus 1 by 2 plus 1 by 3, this is never 1. discarded. Option B, 0 plus 2 by 3 plus 1 by 6, never 1 if we sum. A, 1 by 4 plus 1 by 2 plus 1 by 3, yes, this gives 1. And 0 plus 1 by 2 plus 1 by 2, yes, this gives also 1. Now if we put x, so we have only two options, C and D. Now if we put f equal to x, so integration 0 to h x dx, this is equal to h into a, f0 means 0, plus f h by 2 means h by 2, because fx equal to x, and then c f h mean h. Okay, so this is x square by 2, and if we put the limit, then this gives h square by 2 is equal to h into bh by 2 plus ch. Okay, so now h goes to cancel, and this side also if we take h common, then h square, and since h not equal to 0, then this is half is equal to b by 2 plus c. So c plus b by 2 equal to half. Now if we check option C and D, so in option D, b by 2, that is 1 by 4 plus c 1 by 2, this is not 1 by 2. Okay, so option D here goes cancel, and from this option C, if we verify, then b by 2 means 1 by 4 plus c means 1 by 4, this gives 1 by 2, which is verified. So option C is the correct answer. Okay, now goes back to this Fourier cosine transform. Now the Fourier cosine transform, the formula is 1 by root over of twice pi, I think. So I will solve this problem in the next lectures. Okay, so 1 by twice pi or root over of twice pi, so there is a confusion. So I will solve these questions in the next lecture. Okay, so these are the questions for today's session. So if this session is helpful for you, then obviously give a like to this video, share with your friends, and don't forget to subscribe the channel. Okay, so thank you for visiting. Bye.